So here's our question. We have a hiker walks 22.0 kilometers north, then walks in the direction 60 degrees south of east for 47.0 kilometers. How far is he from where he started? So if you're having a tough time with directions, draw the compass in the corner of your page to begin with. So I have north, south is down, east is to the right, and I have west. So we are starting, hiker walks 22 kilometers. So again, a scale model is ideal, or if you cannot, so with 2. So I just went 2.2 centimeters in that direction. And let's have a second vector. So it's 6 degrees south of east. So this is east, and I'm going to swing south of east direction. So 60 degrees, like something like so. So around 4.7. So we can see my resultant vector is from the beginning to the end. So that's what I'm trying to find out. What is the length of that? And we actually just saw, if I actually delete that line, you can have a little approximation of what that length actually is, because this has a little ruler function. We see this is approximately right, so we want to find out what that is, as well as what the angle is right here. What is theta? So here we go. We know this one is 22.0 kilometers. That's going straight up. And when we look at this one, we say, okay, this line that we drew has an x component as well as a y component. So we find those x and y components, we can very easily just add the x items together and then add the y items together, and we can figure out the overall height. In this case, we're actually going to be subtracting, though, because it's going up 22 and then down some y length. So this is 47 kilometers. And this angle right here is 60 degrees. So again, this is our Vx, this is our Vy. But we already know that this is the adjacent of that 60 degrees. So we say, oh, Vx. We call that, I think this is V2x. Yeah, we can actually say, oh, what's the magnitude equal to? It's just equal to 47.0 kilometers multiplied by cosine 60 degrees. Now that comes out to be around 23, right? 23.5 kilometers. In this y direction we have, that's going to be V2y. That's equal to 47.0 kilometers. And that's going to be sine 60 degrees. So that comes out to be 40.7 kilometers. You can add directions there as well. So this is south, this one is going east. So now we can look at this green triangle. We say, okay, this green triangle has an x component and has a y component. We can very easily see what those x and y components are by looking at our numbers now. We say, oh, this x component is the same as this length up top, V2x. That is 23.5 kilometers. This y component is actually just the subtraction of these two numbers. So we notice how this 22, we're going 22 up, but then we're going 40.7 down. So 40.7 minus 22.0 gives us the length right here, which is actually 18.7 kilometers south. So we now have the x component and the y component. The other way we can approach these ones is the table method, which we touched upon last day. draw the little table. I say, here's my x, here's my y. I say, okay, I have vector 1. Vector 1 has 0 x component, but it's positive 22.0 kilometers up. For V2, you can see that it has a x component of 23.5 kilometers, and it has a y component of 40.7 kilometers. But because this one is going down, I'm going to put a negative in front. Now we can see what the resultant is. So we have our overall resultant vector, 23.5 kilometers in the east direction. And we can see 22 plus negative 40.7. That comes up to be negative 18.7 kilometers. So it's just purely using numbers. This is more of a diagram method. Both work, just what do you prefer? So now if we want to do is find that length and that angle. So okay, a squared plus b squared. And then we can square root those two numbers. So 18.7 squared plus 23.5 squared, square root. And remember my estimate was 30 kilometers. It does come out to be almost exactly 30 kilometers. Got 30.0323. We're just going to round to 3 digits though. So there's my vector v, 30.0 kilometers. However, we also need to find the angle right here. So we have the x and the y components. So I can use inverse tan. You know that theta is equal to inverse tan. And that's going to be the 18.7 over the 23.5. 18.7 divided by 23.5. And we get 38.5 degrees. And that is also going to be south of east. And if I do 90 minus that angle, we get 51.5 degrees. I can write down east of south. Both are correct.